I was stalling. Hello and welcome back to Statistics. We are talking about section 1.2 on sample and random sampling, simple random sampling. We're going to see the ways of obtaining samples and so on. So simple random sampling. First, we'll say something about census. So census is surveying entire population. So we are or obtaining information. I don't know. They don't like the word surveying. So let's use the same wording. Obtaining information for the entire population. Obtaining information for the entire population. So that would be census. And I'll point the arrow and say very, very expensive. You have to reach people by phone, but they don't have a phone. You have to reach people by mail, but they don't have a mailing address. You have to reach people by going to their house. They're sitting on the other side of the door with a shotgun. It's very, very, very expensive and dangerous to obtain census. So what is the better way? The better way is to survey the sample, the part of the population, and then use inferential statistics to draw conclusions about population. The bigger the population, the bigger the sample should be. Smaller population, smaller sample. So there are certain rules that you need to use, and we'll learn some of those. So now, two methods other than the census for obtaining information are sampling and experimentation. So we are looking at other ways. And that's going to be sample. So we are looking at number one, sampling, and number two, experimentation. So these are the two. So for sampling, eventually in the course we will deal with probability sampling, not now. Now we are focusing on simple random sampling. So that's technically the title. And there are ways. For instance, if I would like to survey 10 students in this classroom out of 30-ish of you that are present, or 30-something, to learn about whether you like statistics or not, for instance. It wouldn't be good to pick, because there are various biases that could be skewing the result. If I pick some of the students that I already know from before, and they don't want to disappoint me, they would say, yes, I like the statistics, obviously. Or you might even say, oh, well, the professor is asking me if I like his class, so of course I'm going to say yes. You see that's an issue, right? So what I can do is I can do the random sampling by taking all of the names and placing them in a hat or a bag. It's always a hat. No one wears hats anymore. I mean those, magician hats, top hats, to pick stuff from. So put all of the names in a bag and then just randomly pull names, 10 papers out of there. That's perfect, right? That can work. Placing those names on the wall and throwing a dart, and then whatever the dart, right? But if you are a good dart player, you can actually pick the people, so that when blindfolded throwing darts, forget the papers, directly at you, whoever says ouch is the person chosen. That is also good in random sampling, right? Piñata with a baseball bat is another one, right? You just have to be arranged in a circle around me. There are many ways in which we can do the random sample without picking exactly the people that you want. So that's what's important, the word random. It has to be random, it has to be by chance. It cannot be you picked exactly the ones that you want. So the definition of simple random sampling and simple random is the following. Simple random sampling, a sampling procedure for which each possible sample of a given size is equally likely to be obtained. So, a sampling procedure for which each possible sample of a given size is equally likely to be the one obtained. Oops. There we go. So that's our definition. And what it means is simply, as you are picking 10 papers from the hat, you will pick 10 out of 30 names. You have your sample size 10 names chosen. If you put those papers back in a hat or bag and you mix it all up, you will be able to pick 10 papers again, and probably you will have, most likely, you will have different sample, and you can see that no matter how many times you do that, you will always be picking 10, and they will be different, and there is no really reason why one sample would be more likely to be picked than the other, because all of the names are in the same bag, all of the names are the same size of the paper, all of the names, right, are written by the same pencil or a pen, so you can't really tell, by touching the papers. You say, okay, this paper is bigger than this one, and so I'll pick all the smaller, right? So there is no way to pick exactly same sample twice at random. So that's sample, and then a simple random sample is a sample obtained by simple random sampling. That's that. So, simple random sample: governor, lieutenant governor, secretary of the state, attorney general, and this is arbitrary. Okay, that sounds appropriate. So, what are all of the sampling Oklahoma state officials? The top 5 state officials of Oklahoma are shown in the table. Consider the 5 officials populational list that list the possible samples without replacement, samples of 2. Well, what are all possible? samples. It could be governor and lieutenant governor and secretary of state, and then governor and attorney general. So you can create all of the samples by simply going through it. Now, which one you're going to pick, that depends what you pull out a hat. So it's not just, these are possibilities. This is everything that is possible. What you're going to pick depends on when you do your experiment, when you actually pick. So to translate this particular example to this classroom, if I have 30 names in the bag, in how many ways I can pick 2? Well, that's going to be a lot, right? Because imagine, each student can be paired with any other student. That's a lot of, if I want a sample size 2. Now, when I list all of the possible sample sizes, I'm still not picking it, I just listed them all. When I pick 2 students at random from the hat, I will match it to one of the outcomes. So this is just what all of the possibilities are, but to pick something, you actually have to go to the hat or a bag or whatever, and then pull the name from there. So that's just the procedure. So now, is there a way for us to do this without this work of getting the paper, ripping it all out, and putting it to the size, writing all the names, putting it in, right? Is there a way for us to do this? And the answer is yes. We can use many different online tools that are already there. You can ask Google to give you a random number. I can, just by chance, this is what we can do. For instance, I ask a question in class, what is the mean of these 5 numbers, and no one is answering. On a roster, you are all alphabetically arranged between 1 and 40. So in Google, I can just ask Google, right, and that would be the person that I would ask to give me the answer. If no one wants to answer, what's the mean or whatever. So I say random number 1 to 40. And there you go. Google says 23. So whoever is the 23rd on the roster, your last name probably starting with M or N or something like that, you would be answering that question. So Google gave me, all I did is I typed in the Google random number 1 to 40. When I push enter, it gives me 23. Now, as you can see, the next website is the random number generator, 1 through 40. It generated 9. If I go back to Google, still 23 there. Here is another. Start now. And we exit in this one. Because it's going to, random org, there we go. So smallest value, highest value, 40. I want one number, get it. No, that's not what I was looking for, but there you go. Right. So this is the order in which you will give the answers, right, for the next 40 questions. So because I didn't read the parameters, I just assumed, whatever. So these are there are ways to generate data, and random number tables and random number generators online are the popular ones. So we have 5 minutes, so we'll just take a look at this real quick, and we'll continue on Wednesday. So random number tables. So random number tables are in your textbook. And front or in the back, it's somewhere. And it looks like this. This is a random number table. And it has the line number. And it has the column number. And what you do is you poke your finger somewhere, and then depending on whether you need the 2-digit numbers, 3-digit numbers, whatever, you just go down in the fashion as you can see over here. So if I want 2-digit numbers, I poke my finger there. I poke my finger here. Here.
There you go.
Thank you. And I see 78, right? Because I put my finger between 7 and 8. I want 2-digit numbers, and I want 5 of them. So 78, 89, 10, 67, 07, and 60. Do we really want to use this with all the online tools? No. But do you have online tools on your exam? No. So you have to use this. So your textbook, and I see you have the textbook, mine is all the way in the office. This chart, can you please check? It's somewhere in the front, in the first 5, no, before that. Or attached to the cover, or in the back. So it's somewhere in the book. It's in the back? Thank you. So it's in the back of the textbook. You have a lot of different tables there, so you just need to make sure that it's the correct one, because you will have the z-scores and the t-scores and all of these other charts in the back. One of them will be this one. You can make a copy of it if you want to practice, right? You don't want to be dragging books as you go out, right, to the front. You don't want to carry the book. Just bring the random number copy, right? Because it might come up. You don't know, right? So that would be one way to, and one thing that I forgot to mention is that if you run out of the numbers, then when you hit the bottom, you turn around and you start picking numbers from them. Now, these random number generators are part of computer software, so you can always generate numbers randomly using software. And here's another one where they show in which way you should go down the column, right? And then go up 4 extra numbers. And you just snake through, always taking the 2 numbers. If you need 3-digit numbers, like in their example, you use 3-digit numbers. And if you have a range, as you can see, they're crossing off all of the numbers that are bigger than so apparently nothing in 700, 800, 900. So probably they're, not between 1 and 728. So they crossed those out and they kept looking for more and more until they had enough numbers for what they wanted. We'll continue and finish this lecture on Wednesday. The homework will open, so have fun with that, and I'll see you in 2 days.